So, hi everyone, and I'm guessing that I just have to wait for a few people to come online. I have some people luckily helping me out and watching. If how many viewers we have, I know we start at 3, but I'll just give you all a minute before I dive into this webinar, which will be about equipment connectivity in lab digitalization. Just give you all a few seconds. Good. I'll start slowly diving in. So this is a first for us at Initi to do this in this kind of webinar in this kind of way. And we're quite excited. It's a streaming directly on LinkedIn, where you probably are right at the moment also. And if you don't have a chance to watch all of it, then you will be able to find it on our LinkedIn page afterwards. And also reach out to us and we can supply the videos if you would like that. I'll steal away probably around 25 to 30 minutes of your time today if you stick for the entire thing. My main focus here will be to split up in 3 parts. I will talk a little about equipment connectivity in labs and how that is a natural next step for the digitalization processes going on in labs all over, in R&D and QC labs. Then following this, I'm going also to speak a bit about how you can start working and start implementing connectivity solutions in your laboratory. And then lastly, I'm going to put a few words on how we at Initi actually work with this. I'm going to kick us off by just putting a few words on Initi and myself. So Initi, we are a global connectivity solution company. We launched our solution in 2019. Today we are a little over 20 people. We call ourselves lab enthusiasts and connectivity engineers. Our typical client, typical companies that we work with are global players in life science, biotech, and the process industry, ranging from food and beverages, ingredients, and so on, into chemicals and so on. Myself, I'm Thomas, and I'm the Chief Commercial Officer here at Initi. I have plus 10 years of experience working in transformative technology, and my main focus in the last 2 years have been working with laboratory connectivity. So I would say I know a lot by now, but I'm always eager to learn more, and I'm going to show you some of the stuff that we've learned already throughout the last 4 or 5 years of us being in the market. Good. So just really briefly on Initi, our solution is a connectivity solution that enables you to connect to any laboratory equipment. And when you do that, you have essentially 3 ways of utilizing that connectivity. You can automate your sample tracking, your data logging in your labs. You can control and program your lab equipment, and you can also monitor your lab from any time at anywhere. And then, of course, we also offer seamless integrations into third-party applications such as your LIMS service, your ELNs, any other database that you might have. We are no sort of code solution, so you don't need to be able to code to actually use our platform. And we also supply full service solutions in that sense. We typically say that we want to stand out by being the company that connects with most equipment. I'm going to speak a bit about that later. But today we connect with around 1.5 million different types of equipment. And we are equipment agnostic, so we work with all kinds of vendors and connect you to all kinds of different laboratory equipment. And a main sort of feature that we have, or unique thing, is that we can reduce the time spent on manual data logging with up to 70%. Good. So that was Initi, but let's talk a little about laboratory connectivity in general, right? So if you're listening to this webinar, undoubtedly you are sort of interested in digitalization of labs, and you followed that sort of the theme in the last few years. And when I go to this next slide, you would recognize some of these many buzzwords that is floating around. Some of us, myself, are going to the Future Labs live in Basel next week. I hope also to see some of you there. but just at one of these events, you would see smart labs, LIMS systems, cloud computing, AI is of course filling up everything right now, also outside of the laboratory sector, design of experiments, future labs. There's so many different things to consider and to take into consideration in this. And what does all of these terms actually mean? That is sort of the big question. So for this presentation, I'll try my best to avoid any of these popular words and try to be very tangible in how we believe work on this could be kicked off. That doesn't mean that we don't, we buy into some of the philosophies and all of that, but in general, we work in a very tangible way with the changes in the digitalization of the labs. So, and you can hold me up to that challenge. So if you hear me use any of these words, then call me out in the comment section beneath, or do something in that sense. Yeah, good. So first off, we did a mapping of how the digitalization of the lab in our perception looks today. And we work, as I mentioned before, mainly with major global or international companies that has big R&D, QC departments, and thereby also big lab facilities. And we see right now that we sort of identified a 4-step process to going from having nothing in the lab and to actually having sort of the wet dream of the autonomous automatic lab. The first step being supportive software, deploying supportive software, organizational-wise LIMS, ELN services, analytical suites, and stuff like that. Many of the companies that we work with has done that. Here it says 60%. I think the number is growing day by day at the moment, it's hard to find labs today that are not in the process of deploying a LIMS or ELN service of some sort. But going from that and to sort of the wet dream of having the virtual and AI-driven lab has a few steps before you actually get there, right? So it's not just enough deploying a good LIMS or an ELN. You also have to take a few steps before that. And one of the first things that we've identified is that you have to control your data streams. And today, even though we have a lot of LIMS and supportive software, we see a lot of manual documentation going on out there. We see pens and papers, we see fragile USBs and so on being transferred around the organization. So a natural next step is also to start that organizational wide data logging, which will then again enable you to start automating some of your lab processes. And then in the end, you can then deploy really, really smart services and solutions, technology into this while you have control of your own data and your processes. But there's a few steps, and I would say the main focus for a few years have been on the supportive software, and I think it will now move into some of the later stages, and I'll speak a little more about that. My main focus is, of course, connectivity in labs, and I want to just start kicking off and saying I brought a quote from one of our clients. It's not a direct quote, but it's very similar, and it looks like this. And I was thinking, if you have been working in lab, you might actually recognize a scenario like this. So this is where we ask the client, how do you actually transfer the data from an analytical equipment into the endpoint, which is a LIMS system. So they say, first we export the data into a PDF, as a separate PDF into a USB, and then they print that out and they scan the PDF and combine that into one digital document. And then they copy paste the information from the document into an Excel sheet. And then finally, they transfer the PDF and Excel sheet into a LIMS system via another desktop that is online. So this is like, it sounds crazy, but if you look at your own processes, I would guess that you have similar stuff going on different places in your organization, and it's very normal. And I would say when I entered this industry, I was a little surprised, saying, okay, this is actually going on in 2021 when I started, and now today in 2023. But it is, in fact, and I think one of the, I'll come a little back to why the challenges are and why this hasn't changed as fast as you would imagine, because it's not always easy, but there are solutions for it. But let me dive into a little of the challenges and pains that this lack of connectivity actually offers, because having tedious transferring of data is not the only thing. Some of the things that we've identified, which is connected to lack of connectivity in labs, identified pains that are connected to a lack of connectivity in labs, are that you have increased manual documentation, you have loss of data, your USB keys breaks down, or your PDF, or someone forgets, or whatever. You have more errors because you have manual inputs. You have time spent on backtracking these errors or doing reruns because you don't understand why that comma, maybe it's a comma set on the wrong place. You have a continuous need for monitoring for experiments and trials. And of course, all of this, because some people are better at doing this than others, and some are experts in this specific instrument and documentation, this also gives many organizations a high key person dependency risk. And what does that mean? It essentially means that you have a few people that knows processes and operating procedures very well. And if they're suddenly not there, or they're on vacation, stuff like that, things stop happening in your lab, and that is actually a pretty costly thing for any organization. And of course, all of this amounts into slower go-to-market design in R&D, and also slower testing QC, slower delivery of valuable test experiments and trials. So you might ask, okay, Thomas, when this is the case, why hasn't all lab equipment been connected? So at this moment, we believe that maybe 5 to 10% of all lab equipment is truly connected. That means that it's actually connected directly into the source where the data needs to go, and not just to the internet. So there's a few answers to this. And the first one is the realization that laboratory digitalization is a change management process, right? And with any change comes also a need to stop doing what you're doing and think about how we could do it differently. And that is super hard when you're working in a macroeconomic environment right now, where positions are being pushed and everyone have to work harder and so on. We experience, at least, that there's a lot of clients having a hard time taking that necessary stop and actually taking their time to improve. And this is a picture or illustration that I borrowed from a third party, and I think it simplifies very well what we also sometimes experiencing, that you are driving these squared wheels, and there's a much easier solution to do it, but it also requires that you accept that you have to stop for 2 seconds to find out a new way of doing it. I want to mention also, if you have any comments, any ideas or questions, feel free to push these into our comment section. I have Serbi and Josephine sitting by, and also they will help answer questions. I will be unable to see, but they will also let me know if there's anything I need to focus on. Apart from that, if you have any sort of, if this also reminds you of your situation, feel free to share also in the comment section. Yeah, going back to different reasons, one other reason that we see is that we see many organizations actually starting initiatives on laboratory connectivity. And what typically happens there is they have the best of nature, and they want to kick off this project and say, we want to have all of our laboratory equipment connected to our LIMS service within the next foreseeable future. And then when they start scratching their head on that, they find out they have many different ELNs or LIMS service or software applications. They have many different types of equipment. They have many different kind of needs. And suddenly this grows into sort of a big monster. And typically we see that it starts out as a global project based on popular demand from local organizations. And then no one ever hears about it again. And then suddenly it bulldozes in and saying, now we're doing this. And but it just takes forever. So it becomes a 2027 project or a 5-year project or whatever you want to call it, which is of course also, and that's what we call a scope creep, where a good intention ends up growing into a huge project that no one can really take on. The last main reason we see for, as a barrier for holding back the realization of connectivity in labs is there's a misperception of value drivers in the digitalization process. And here I have my four-step approach again, or four-step process again. And as you can see here, we typically have identified that, and this comes specifically very often from the top management, they have this idea about that there will be no value of this process before we are at the fourth phase, where everything is automatic, right? Because we've seen ChatGPT and we've seen these processes going on. Why can't we have everything like that? And from where many organizations, I would say most organizations are today, it's quite of a long haul. And what we also need to challenge the people that are not inside the lab about is that, there is a value realization way before that, because change management, as mentioned before, is not a direct process where you go from A to B. It's a step-by-step approach. So we see actually a reality where you take one step at a time, one iteration at a time, and then you learn and you get more and more insights, you create more and more value throughout the phases. And in the end, you get to the sort of the golden nugget of it all, which can then be your golden dream, which very, very seldom, or I would say almost never, looks like the one that you imagine it would be. So it's a step-by-step approach getting there. So the main sort of challenges we see again is lack of prioritization to actually set in the change and prioritize the change. When you start prioritizing the change, having that challenge of growing into a monster, the project going into its own monster, and then lastly, also not understanding where the value drivers are. So for us, the question is, of course, so how do you get started on this? Because, okay, the barriers are there, we have to tackle those, and how can we do that? So for us, we have one major sort of guiding principle. We believe that change projects in lab digitalization should be tangible, value-driven, and pragmatic. And if you start by that, then you can get very, very far, and you can create value very, very quick. And we typically work with identifying, and this is a term that I borrowed from some of our colleagues in the consultancy industry that we work with, identifying no regret moves, stuff that you would never regret that you did in your processes, where you said, why don't we establish this and get that up and running so that we can start creating value. So that could be, if you're today having HPLCs, 10 HPLCs running 75% of the day, and you're having actually two people just going in, putting manual data in from these processes into from one machine to another machine. So you will never in your lifetime regret that you set up automatic data transfer on that. You can always discuss if you should use one solution or another, but in the end, if you create a solution fairly quick that actually solves this, then you would never regret that. So that is an example of, for us, what we see very often is a tangible, value-driven, and pragmatic solution for getting started and creating value. So we split this up into 5 steps, actually, because it's just saying that it has to be this is fairly easy, but how do you actually operationalize this? We work with this 5-step value approach. The first step is to identify these no regret moves that I was speaking about before. You could also call them valuable use cases. So together with our clients, we would identify a process that, when it's digitalized, would bring quick value and be set them off better than they were before, and also to do something that is quick and also really quickly valuable for them. The next step is then to operationalize the solution, set the connectivity up, and it actually is not as hard, I'll come back to that, as you believe it is. That's what we work with every day. We connect laboratory equipment to third parties all of the time. But we set that solution up and get that up and running, typically something that takes 2 to 3 months, I would say 1 to 3 months after we have identified the use case and we have all of sort of the things in order on that. Then we operationalize the solution, and that is an exciting moment because that is when we bring it in and set it up, but also change your ways of working. And typically we see that 50% of the ways connectivity solution changes the work and operational workload in a lab is identified before it's actually there. But the last 50%, the last half, is not realized before you actually have the technology in your hand. So that's where you start thinking, okay, if we can do this and this, we can eliminate this paper trail here, and we don't have to use this USB anymore, or we don't have to stand here and wait for the results, or we don't have to monitor, come back every 15 minutes to monitor. It opens up for new thought systems and belief systems that both you and also your co-workers working in the lab actually identify and say, what if we did this instead? And then you start really bringing value. So the next step for us is also to set down what we call a value workshop, but it can also be sort of an evaluation on the project, saying, now what kind of value did we create? How can we learn from that? How can we use that in other prospects or on other projects or other processes? So we typically work with this organizational wide, saying, okay, we had this cool project, let's say in Berlin, and now it's deployed, it's bringing value, people are working in a different way. We did the change and we saved time, we saved resources, we had a better result. And then we bring this out to some of the rest of the R&D or QC organization or pilot production organization and say, is this something we could learn from? Is that something we can use in other places? And then from there, we basically scale the solution. So going back to my step-by-step model, this is exactly what we do. We take one step, gain value, and then we take the next step. And I don't think this is unique for us at all. So this is also something you can deploy in your everyday work, and when you are doing this change management process, because it's constant, you are doing constant change management when it comes to digitalization, and you will be doing that for the next 10, 15, maybe more years to come. But this is our take on it. So, okay, good. So there is actually a way of solving this. But what would happen next? Because, how does it work? And if you're working in lab, you would recognize some of these questions might already have popped up. Can a solution like yours need to connect with legacy equipment? We have old HPLCs, we have some old incubators or whatever. What about the IT policies? Our IT department, they would never let us connect anything to the outside world. They are very hard to work with. They don't have time. Does it work with our typical equipment software, my Chromeleon or OpenLab or whatever it can be? And what about my LIMS? How does that fit into all of this? So I have answers. I answer these questions every day together with my coworkers. They are good answers and definitely tangible solutions. Also, regarding the IT part, we actually find that to be less of a barrier than anything else. But I'll come back to that. For now, I'm just going to give you show you a few slides on how we actually work with this and how our solution actually works. And if you want to hear more about this in the future, I'm also going to give you some tips on how you could reach out to us and maybe start a conversation on this. But typically, the equipment that we connect to ranges from what we define as general lab equipment, which can be equipment that you use for measuring, sensor equipment, heating, cooling, mixing, and stirring. It can be your scales, your balances, your valves, your pumps, and so on. A lot of the stuff you have in your sample lab, you have in your preparation lab, and so on. Then we work with our advanced analytical equipment, so everything from GCMSs, HPLCs, liquid handling robots, and so on, that has an advanced output with many data things in it. And then legacy equipment that can be a bit of both. Your old HPLC that doesn't really offer any, with an outdated software, whatever it could be, to your incubator from 1992, or your stir from also the last century. So we connect with these, and let me tell you a little more about how we actually connect. So we have 3 ways of connecting. Our preferred way is deploying what we call a virtual connector. The virtual connector is a small server-driven connector that we use for equipment that already has a Ethernet port or a network accessibility. So this would be some of your advanced analytical equipment, and also, in general, I would say advanced equipment that offers an Ethernet port. We would deploy that small connector, and essentially what it does is that it understands the protocol and the language of that specific equipment, and it translates that and normalizes that into a raw data file. So you get exactly the same data that you see on your equipment. Another way, another connector that we have is our desktop connector. This is very often used also for HPLCs that has a desktop connected to it with a software, let's say Chameleon or OpenLab or whatever it could be, Waters for that matter, where instead of deploying a virtual connector, we deploy a small software application on the desktop that is connected to the equipment that does the exact same thing. It carries the protocol and the driver of the equipment so that it understands the equipment and can actually send the data into our suite. Then the last connector that we have is mainly used for general lab equipment and legacy equipment. It's a small box called the Initi Physical Connector. And it's basically a box that does the exact same thing, but it has all kinds of ports so that it can connect to RS-232 and all kinds of other ports of any kind, and enables us to write a driver that can speak to both your old stir, your Mettler Toledo scale, or whatever it could be. So with that in mind, we take the data, we transfer that into our cloud, and we have a cloud-based environment which is hosted by Microsoft Azure. So typically that's something IT departments they really like. We can also you can self-host that. You can also have that hosted in an AWS environment if need be. But the magic really happens now that we have captured the data and we bring it into the cloud. What happens then? So in our platform, you have 3 central features that you can utilize the data with. Our first feature is our control and automate. This is where you can set up conditional workflows and execution manuals to control your equipment. So let's say that you have a filtering mechanism that you want, you have a flow meter and a pump and a filter in between, and you want the pump to pump a specific amount of liquid every minute through the flow meter. And you can then set up in our solution a simple feedback loop, a PID tuning that enables you to, basically control and program this amount of liquid going through the filtering mechanism every minute. And this can be thought out in a gazillion ways where you can control and automate your lab processes in this way. So this is our control and automate. Then next to that, we have our track and trace, which is all about getting that full granular data tracking of your lab processes, your sample management, and so on. So basically understanding, for example, with a sample, what happened with that specific sample at what part, all the way from preparation lab or into the analytical lab, and also covering the results and transferring that into any third party that you would need. The last part that we have is our monitoring interface, where you can essentially set up monitoring on all of your laboratory equipment and keep an eye on that. So you can have your bioreactor processes running on a screen to make sure everything is working as it should. You can have your thermostats with your pH measurement or water bath with your pH measurement combined, making sure that they're there. And you can set up alarms so that if anything out of the ordinary happens, you get notifications to your colleagues or yourself on text or email or whatever you want. And the great thing about this is that it doesn't really end, because we realize that our solution, our platform is very often not the end destination. The end destination very often is either your database or your LIMS service or your ELN or whatever. And that's where we work a lot with third-party software integration via REST API, where we can do it in essentially the the fashion that you would like us to, either by native integration or by doing a more open integration where you can control the output yourself. Let me just give you a few examples on typical projects that we do for clients. So one project could be that we do sample tracking and data logging of advanced analytical equipment. So that can be automated data capturing and transfer of sample management and so on, all of the results connected to the samples, and essentially all of the stuff where you every day today are filling in a manual document in hand, or you're transferring PDFs in via USBs or something alike. Basically removing that entire paper trail, saving all of that time, and also making sure that we minimize the number of errors connected to this. This means that you have fewer reruns. It means that you have less time spent on backtracking and so on. Another example could be automation of a filtering or fermentation process of any kind. So our control and automate is very often used for continuous processes, where we every day we have clients using our solution for filtering mechanisms and fermentation processes, and where they can control and set up these feedback loops and also conditional process themselves using drag and drop into our platform. So again, no coding is required, and we also help assist with the PID tuning should you need a feedback loop and so on. Then the last part is the conditional monitoring. It could be conditional monitoring of your long lab experiment processes, where you have to check up on these. Sometimes we hear that labs put processes on pause, and they say, like, I have to put it on pause now, I come back tomorrow and I start again. And you could essentially have that keeping running, and then having our monitoring interface keeping an eye on it for you and sending you alarms if something should happen. And you can also combine these features where you say, okay, if that happens, we want our control and automate to shut down the experiment, for example. So these are some examples that we work with. We will actually set up a webinar very soon, or an event on where we will have one of our clients, or actually two of our clients maybe, join us for a conversation on how they have worked with some of these challenges, and how they have implemented solution, and what kind of difference it has made in their day-to-day work. Also to make it even more tangible for you that wants to follow. But until then, this is essentially what I had, and I wanted to share with you today, and I hope it makes sense. And I would love to expand on this, both me and my colleagues. So if you're interested in learning more, we right now offer anyone a possibility to schedule a free and also non-binding assessment of the potential of the laboratory connectivity in your lab, where we set up together. We have a few conversations. Maybe we take a tour of your lab, either virtual or we actually go there physical, and we try to sketch out, okay, what kind of processes would we be able to change? What would it mean for you operationally? And also what would it entail when it comes to return on investment in doing so, which is it's fundamental for getting any kind of change management project approved, of course. I don't know if there's any questions, because I wasn't able to see, but I will count on my colleague here to answer these. Yes, okay, there's a question here. I'm just reading out loud. With regard to selecting the first valuable use case, would you pick the one with the biggest impact, or one with the smaller impact that is easiest to introduce? So that's a super good question. Actually, that's very often the part of the assessment that we do with our clients. And I think there's one element that really plays a role here, is if the one with the biggest impact has the same operational influence, or you have to change your operations in the same level as the one with the smaller impact, then I would always go for the bigger impact. So I think that the two moving parts that we see is how big is the actual impact business-wise, return on investment, but then also how much would it require from you to actually make the change. And I think that plays an enormous role, right? So if our favorite thing in the world is to see big impact and small operational change, right? So that's I would put that into the calculation as well, and then I would choose the one that is the easiest to do and has the also considerable impact. I don't know if it's an answer. There's another question here also. How this approach differs from internal data lake connected to instrument spaces that all possesses sync jobs with given directories of lab equipment. Yeah, so good. So I think what you're thinking about here is if you are able to establish the connectivity to your equipment directly yourself and then just pull the data into a data lake. That is also a super good solution. I would say one of the things we see very often is that you have some limitations. So I don't know which company you represent, but let's say you are a farmer and say, we would always say focusing on the farmer part and then don't spend too much hours on actually having to build these many drivers for doing this, because you'll have natural limitations on some of the equipment that you're working with. But we see that very often it can be a combination of two. Most of our clients have actually done some of this work themselves, and then they have some more equipment that they would like to they don't have the time, they don't have the skills, the competencies to actually connect with. Maybe it's legacy equipment or whatever. So that's where we come in and help with that as well. So it is very similar in that sense. Yeah. Good. Josephine is not writing me more questions, but I'll just keep this on the screen for a few minutes. And then if you're not already following our LinkedIn, I hope that you will take this opportunity. If you want to reach out to us, please do that. You can also find me on LinkedIn, Thomas Overholt. I should also be somewhere in the comment section or something like that. And feel free to reach out if you have any questions, any thoughts on what we told you today. And if you would like us to speak more on this in your organization. Apart from that, I thank you all for joining, and thank you for listening in. Bye.